So, have you ever heard of deep learning? It may sound intimidating, but it is actually something that symbolizes innovation and knowledge all at once. In this presentation, allow me to introduce you to this world of endless possibilities between humans and computers, with information gathered by Group 1. Deep learning refers to a subset of machine learning methods that are inspired by the structure and function of the human brain's neural networks. It involves training artificial neural networks with multiple layers to learn and extract meaningful patterns and representations from large amount of data. Applications for data learning are frequently employed in the business world, in everything from automated driving to healthcare. Following that, the following are some examples of data learning. 1. Automated vehicles. Deep learning is being used by researchers to recognize items like stop signs and traffic lights automatically. It may also be used to detect pedestrians to reduce the likelihood of traffic accidents. A few examples of defense and aerospace include 1. Intelligence and surveillance. It utilizes the capabilities of picture recognition and computer vision to extract useful intelligence. It increases surveillance with automatic identification devices and high-end facial recognition software. 2. Cybersecurity. It creates models that track and categorize shady network activity to find intrusions on confidential data, improving accuracy over time. And 3. Combat systems. UAVs powered by AI can monitor for threats and enhance situational awareness to safeguard facilities and increase the safety of military personnel. 3. Medical study. Researchers utilize this deep learning technique to swiftly identify any cancer cells alongside interpreting different medical images or documents. 4. Business automation. By detecting when workers are in a dangerous location, this deep learning technology helps to increase worker safety near heavy gear. 5. Electronics. Automated speech translation and hearing is one of the applications of deep learning in this field. Google Translate, for instance. That being said, deep learning has found numerous practical uses across sectors of industries due to its ability to learn complex patterns from large amounts of data, derived from the human brain structure and functions. As deep learning continues to advance to solve problems and make intelligent solutions, let us now look into its uses in the context of different industries. Imagine scouring through a collection of old photographs. You decide to have a couple of them framed, but first, you need to sort them out, and doing it manually was the only way to do it. You could arrange them by date, but photos may lack those details. This is where deep learning enters the picture, as images can now be classified based on locations identified in photographs, faces, a combination of people, dates, and the like. When searching for a photo, visual recognition algorithms have multiple layers, from basic to advanced, to recognize specific objects. It improves growth in digital media management by using convolutional neural networks, and it is used in self-driving cars, surveillance systems, content moderation, and medical imaging. Natural language processing is another prominent usage of deep learning. It trains machines to detect subtleties in language and frame appropriate answers using deep learning. Language modeling, text classification, Twitter analysis, and sentiment analysis are all subcategories of natural language processing where deep learning is gaining traction. Distributed representations are very successful at producing linear semantic relationships that can be utilized to form sentences and phrases and retain local word semantics with word embedding. Deep learning models have since transformed NLP tasks like language translation, text generation, and speech recognition. They are the primary force of virtual assistants, chatbots, translators, and voice-controlled products. The entertainment industry also utilizes deep learning in their services. Streaming services like Netflix and Amazon Prime are now improving their deep learning capabilities to provide a more personalized experience to their viewers by creating profiles that consider show preferences, time of access, history, and other factors to recommend shows that may appeal to a specific viewer. YouTube has also used deep learning to develop the next generation of data services for tailored user experiences and by artists, companies, music labels, and company departments to provide insights based on revenue and popularity. Deep learning and its contributions to face and pattern recognition have also made content editing and auto-content generation a reality, transforming filmmaking as cameras learn to analyze human body language to imbue digital characters. Lastly, the banking and financial sector also uses deep learning as it is plagued by fraud detection with digital money transfers. Autoencoders are being developed to detect fraudulent use of credit cards, saving banks and other financial institutions a lot of money in recovery and insurance costs. The prevention and identification of fraud are carried out by analyzing patterns in client transactions and credit scores, along with unusual behavior and outliers. For fraud detection, classification, and regression, as well as neural networks, are used. While it works closely with machine learning since machine learning is used to detect fraud that requires human intervention, deep learning seeks to minimize it by scaling efforts. There are many more uses of deep learning in various ways used in other sectors. As the field is continually expanding, new uses for deep learning continue to emerge as researchers and practitioners explore its capabilities.